Section 8.6. They're asking us to identify the vertex, max or minimum value, axis of symmetry, and then graph the following equation. Well, this is similar to the beginning quadratic functions that we were graphing of x squared. Only before we take x squared, we're subtracting something from it. And if we compare it to this general form here of f of x is equal to something times x minus h squared plus k, we can glean quite a bit of information and the characteristics of what this quadratic equation is going to look like from the values that are in this particular equation. Our leading coefficient a is 1. It's positive, and if it's positive, greater than 0, this parabola will open upward. That means if it's opening upward, our vertex will be at the bottom, making it a minimum. We'll talk about that in a minute. There's nothing being added on, so our k is equal to 0. Everything else is matching, so our vertex will be at the coordinate hk, which in this case will be 3, 0. The axis of symmetry is x equal h, and since h is equal to 3, we'll have our axis of symmetry at 3. We can plug in some values to get the general shape of this. We can also start with the vertex, drawing our axis of symmetry, finding a point or two, and then using the power of the reflective principle with our axis of symmetry to graph it as well. But just to set up a couple values for our equation here, if we let x equal, say, 2, and plug it in, we would have 2 minus 3 is a negative 1, but it's being squared, which is equal to 1. If we let x equal 1, 1 minus 3 is a negative 2, squared is going to give us a 4. I don't know why I did those in reverse order. But we have 3 points for our graph. Our vertex is at 3, 0. We have the point 2, 1, so 2, 1. We have the point 1, 4, so 1, 4. We don't quite have a parabola here if we connect these points, but our axis of symmetry is at x equals 3. Think of this as our mirror line. The vertex is a reflection of itself, but since we are over 1 from our axis of symmetry at this height, by reflection it would mean we have a point here at 4, 1. And just to verify that, if you let x equal 4, we would have 4 minus 3, which is 1. 1 squared is 1, and it's proving out. Likewise, we're 2 away from our axis of symmetry here at a height of 4, so 2 over would put us at this value, and if you plugged in a 5, again, just to verify that, 5 minus 3 would be 2, 2 squared is 4, and we have the point 5, 4. If we connect those points, we do have a parabola that is opening upward. That was our prediction from the start, since a was a positive. Our vertex is our turning point. It is a minimum, so this is, since this is the lowest point that this parabola takes on. Our axis of symmetry we already identified. It is the equation x equals 3 because of that vertical line, and we have graphed it. Our vertex also we have identified, so we've taken care of all the components. Now, how did this compare to that basic equation that we graphed of just simply f of x is equal to x squared, it's the same exact shape, except we've had a translation. Our vertex is not at 0, 0, it's at 0, 3. But as far as its width and shape is exactly the same, with the exception of, as I previously said, it has moved or translated 3 units to the right. What's going to happen in this next equation? They're asking us the same information, and if we compare it to the standard form, we have a times x minus h quantity squared plus k. You'll notice the only difference between this equation and what we just graphed is that our a is a negative 1, which means this parabola is going to open downward. When we compare our values, our vertex, which is hk, there isn't a k, but we can put one without changing the value. We have an equivalent expression, is going to give us that our h is 3 and our k is 0. Furthermore, our axis of symmetry is x equals h, which is x equals 3. And we're ready to graph this. No surprise when we plug in the values into this equation that they will be just the opposites. I'm not going to spend a lot of time on generating some values here, but we're plugging them into the function, whoops, to the second power, just to show you. So if we let x equal 2, we would have a 2 minus 3 quantity squared is 1, 1 squared is 1, but we have to multiply it by negative 1, which gives us negative 1. Putting in a 1, we have 1 minus 3 is negative 2, squared is 4, but the formula says multiply it by negative 1, so we end up with a negative 4. Plotting those points, we have our vertex at 3, 0. That didn't change. We have our axis of symmetry is through the vertex at x equal 3. We found the point 2, negative 1. We found the point 1, negative 4. Due to reflection, we can reflect. We're 2 away from our axis of symmetry, so 2 on the other side would give us that point. And connecting those in a smooth curve, we have exactly the same parabola shape that we had in the previous one. With the exception, it is opening downward because of having the negative 1 coefficient on it. Here is our vertex, already identified at the coordinate of 3, 0. Our axis of symmetry here is this vertical line. And as far as is the vertex a maximum or minimum, because this is opening downward, the largest value that this function takes on is here at this point, and so this becomes our maximum. Let's look at another function that they want us to graph, and noting it to the standard form of a times x minus h quantity squared plus k to pull off those values. The first thing we want to look at is what's the value of a. A is equal to 1. If a is greater than or 0, it means that this parabola will open upward. So we have a mental picture of what this should look like. Our signs don't agree. A minus 2 or a positive 2 can be thought of as minus a minus. Minus a minus is equivalent to a plus. So now that we have it in the standard form, it appears that our vertex, which is the coordinate hk, will be at a negative 2. And we have a similar situation here with our standard form plus k. We have a minus. We'll turn that into plus a negative, so it will be at negative 3. The axis of symmetry is always at x equal h, and our h is a negative 2. Plugging in a couple values then for this parabola, we can let x equal, since our vertex is at -2, -3, let's put up, let me graph that, -2, -3. I want values on either side of it, so I'm going to let x equal a -3 and see what we end up with. Plugging it into the equation for our f of x value, we would have -3 plus 2 squared minus 3. Well, -3 plus 2 is -1, squared is 1, 1 minus 3 is -2. If we put a -4 in, -4 plus 2 is a -2, but squared is 4, minus 3 is 1. Plotting these values, we have a -3, -2. We have the point -4, +1. Our axis of symmetry is going through our vertex. With the use of reflective property, we're 1 away from our axis of symmetry here, so we would be 1 away on the other side. At this height, we're 2 away from our axis of symmetry, so we'll go 2 over on this side, and connecting those, we have, in fact, an upward opening parabola, as our A had indicated. Our vertex is here. Because this is an opening upward, that's putting the vertex at the bottom, the lowest point, so it is a minimum. Our line here is our axis of symmetry. So we've answered the questions as well as graphed, but again, comparing this to our basic f of x is equal to x squared graph, it has the same shape. The only thing is our vertex has been translated 2 to the left and down 3. It has the same shape in that 2 to the left and down 3 is indicated by 2 to the left and down 3 with our HK in the given formula.